All right, so let's just see what we're going to do. So we have to create a Roman numeral converter in Elixir. So I was briefly looking over the problem before I started streaming to make sure that I thought I at least had some sort of idea of how to solve it so I didn't humiliate myself. And I think I have a general idea what the algorithm is going to be, but we'll have to see how we set it up. So let's just start with the first test. So test that converting 1 gives us back I. So if we go into Roman numerals and Elixir Roman numerals test, we get a failure. So let's pull up our module here and we'll just return I to start. Make this 2 spaces. Hey, Chris. Cool, so first one's good. The second one, 2 I's. So, I mean, I'm going to try and think of like a more interesting way to solve this than just kind of and stuff like that. The idea that I have, I think, is that basically every Roman numeral, and it's sometimes pairs because 4 is kind of a special case, they all map kind of to a number, right? And I feel like given any number, if we divide it, if we start with the highest Roman numeral that we have, and divide a number by that number. So say we have like 15, right? And say we have Roman numerals where like X is 10, V is 5, IV is 4. I'm going to treat that as its own symbol, and I is 1. I feel like if we just divide this, if we kind of iterate over this in order from greatest to smallest and divide it each time by this value and then pass the remainder recursively to the same function, I think that will kind of do it. So like if we do, 15 divided by the value at this pair, so 15 divided by 10 is going to give us, 1 remainder 5. So we're going to take this and repeat this string that many times. This is kind of what I'm thinking anyways. So the one thing I'm not sure about is what is the best way to represent that data structure, because maps in Elixir are not ordered, and we need an ordered data structure because we need to make sure we iterate over these from largest to smallest. So let's pull up the Elixir docs. Now, one thing that I think we could do is just create a list of tuples, which doesn't seem like too crazy, right? Like, so we could say create like a constant here called like Roman numeral map or something. And it's kind of ironic that it's not a map, but in here we're going to have things like I is 1. And let's just start with this and kind of work through it and see what happens. So I feel like the way that we're going to implement this is we want to repeat I for as many times as it divides into the number. So it's like we want to iterate over this and get the result of each one. So let's think, what's the best way to do that? Yeah, the 4 case, I think I'm going to handle by treating IV as a separate character. So that when you get to something like 9, then the next options, right, are going to be V is 5, IV is 4, and I is 1. So if we do 9 divided by 5, that's going to give us 1, remainder 4. So we're going to do 5, or V, repeat that as many times as we were able to divide in, which is going to give us, V in our output. And then we're going to take the remainder and pass it through this function again. And 5 is going to be 0 times, so we're going to add 0 of those. IV is going to fit exactly once, so we're going to add 1 of those. And then then we're going to have a remainder 0, and nothing is going to go into that. So I think that's going to work. I'm just trying to think how to do this idiomatically in Elixir. So we have this Roman numeral map. We basically want to get the head of the, true. 9 is IX. So again, IX is going to be a special term. So we're going to have like X, IX is 9. I think this is the smartest way to think about it, because this is not like consistent, right? Like it's not like IM is a thing that gives you 999. So yeah, you're right. I was wrong. Anyways, the algorithm I think is still going to work. It's just a matter of how we're going to do it, because I'm just trying to think what's the smart way to do this. So I know what I want to do. I'm just trying to think of how to actually write the code. Got to turn on my Elixir recursion pattern matching brain. So, I mean, in pseudocode, we want to do like number. We want to do like repeats, is like number divided by the first entry in the Roman numeral map. So we'll say like Roman numeral map. The first one at like the second element or whatever, right? Again, this isn't real Elixir, but and then once we have the repeats, we're going to say our answer is going to be like, I think it's like, what is it? How do you do the repeat in Elixir? I think it's duplicate. So string.duplicate. It's most likely the one. Yeah, so then we want to duplicate. So it's going to be string.duplicate our string, right? Which is going to be this Roman numeral map first value, right? So whatever like our key is, we're going to do that repeats times, and then we're going to concatenate that with the Roman numerals for the remainder, which is going to be remainder of number over that. And I guess we don't need the other items in the map, right? Like, or do we want to pass the whole thing through? Oh, okay, it's confusing. So anyways, the easiest way for me to conceptually think to do this is to write another function so we can pattern match to extract the things that we need. So let's just call this like I guess we can just call it the same thing. Numerals for some number, passing in the head and tail of the map. And then I think it's basically this, except now this is going to be, and this head can actually be a pattern match on the character and the value. So this is going to be divided by the value, and then we're going to call string.duplicate with duplicate the character, repeats number of times, and then concatenate that with the remainder, which is number and value. And then I guess we just want to pass in, like, I think we can just pass the tail of the list. And here I guess we're just going to call numerals recursively with number and Roman numeral map. So we kind of went pretty far here, but no clause matching in string.duplicate. Oh, 2.0. Oh, it's float. Okay, so we need to do integer division. Which is in the kernel module. Div, I'm pretty sure, is the one. Performs an integer division. Okay, so div. No clause. Okay. I also think that rather than just passing the tail, even though that would totally work, probably, I don't think it's like conceptually the right algorithm. Like, let's stick with the tail for a second, see what happens. We'll do another definition of numerals that matches on 0 and anything. And this will always return an empty string. Huh. Would you look at that? So our first two are passing. So 3. This should pass because we do have our, 3 works. So 4 is going to be the first one that fails because we haven't added that entry to our map yet. So we got 4 i's back instead of IV. But if we go to our map and just add IV and map that to 4, I think it'll be good. Syntax error, missing a comma. Yeah, it worked. Okay. 5, this is going to fail because we haven't added that to like our symbol table yet. So again, we'll just say 5. Cool. 6. Now this is where we're going to find out if our algorithm is working as expected. And it is. Pretty epic. IX, so this is going to fail, and then we're going to have to add IX to our symbol table. So IX is 9. Okay, this is a kind of an interesting one. If we did it right, we'll just get it for free. Ooh. Interesting. Oh, we haven't added 10 yet. Okay. Yeah, sure. So I'm being asked, do you mind explaining the syntax? I'll type in chat so I get a response faster so I can answer. I'll go over just kind of it in general, and if there's anything in specific, just mention in chat if you want me to expand on it even more, and I will talk about it. So this is a module attribute. All we're doing here is defining a constant, right? So we're just creating a list of tuples that have the character and what its actual value is. So this is pretty straightforward, but it's important that it's in order from largest to smallest. This function, numerals, is the one that's getting called from the test. We're doing a pattern match. Elixir is doing a pattern match for us to pick the right numerals function to call based on what parameters it gets, right? So when we call numerals 1, it looks to see, okay, we've got 3 definitions of numerals. Which one should I use? It can't use this one because this one's expecting a number. Then it's expecting a list, or an array, where the first element is a 2-element tuple and it has a tail, which means it can't be an empty list. This one is saying anytime numerals is called with 0 as the first parameter, and I don't care what the second parameter is, it can be anything, give me an empty string. So what we're doing is when we get an integer passed in to this match, right? So let's go with like a kind of an interesting example. Say like we're looking at this one, right? So we pass in 27. So if we're stepping through this, we get 27 passed into here. And then what we do is we call this version of the function with 27 and then our map, which is like our constant, right? And the only reason I pass this map in is pretty much purely to pattern match on it here. Just because I'm learning more and more that the right way. So I've had problems in the past in Elixir where I've passed a parameter and I didn't know what to name it because it just happened to be like a tuple of 2 things that I did have good names for. But the tuple itself I didn't have a good name for because that data structure didn't really mean anything to me. It was just like a bag for me to pass the stuff around. So I'm learning that the right approach is, hold on, I'm going to sneeze, I think. The right approach, we could just pass like a parameter here called L, right? That would represent the list. And then we could say that we could do something like, tuple equals the head of the list, which is giving me the first element of the list. And then we could say character equals, I think it's like tuple.get, like tuple 0 or whatever to get the first element of the tuple, right? That is not even remotely the right way to do it in Elixir. So first of all, just backpedaling slightly, the better way to do this call, right? And we'll kind of bubble up and solve all this, but the best way to do this call is not to assign char to whatever we get from the first element of the tuple. It's instead to match against the whole tuple and extract it into a variable called char. So this match is going to see that this tuple, like the underlying tuple on that side, right, is going to be something like x10. And if we do char value here, after this line runs, char is going to be equal to x, and value is going to be equal to 10. So it's like it's kind of similar to like using like the lists function in PHP or something, I think ES6 has like a similar thing for like unpacking arrays like this. So anyways, knowing that, right, this tuple call becomes totally not useful. So we can actually just say head of the list matches to that. And now we have the char that we want, right? And head of the list, well, that's actually can be done in the parameter list too. So instead of saying list, we could say head and tail, which is going to make h equal to the very first element of the list. And t is going to be a list of the remaining elements in the list. This kind of seems weird to people at first, I think. But lists are like linked lists in Elixir. So you really just have an element and that points to the next element, which points to the next element. So this is a list of every other item. So like if we passed in a list that was like 1, 2, 3, 4, 5, right? And we pattern matched against it, H would be 1, and T would be the array 2, 3, 4, 5, right? So again, we can get rid of this head L call by pattern matching in the parameter list, and then we can just say H, right? Well, then you see this and it's like, well, can't I take that even one step further? Well, I can just move char value right into here, and that gives me the whole thing. So now I have the char and the value immediately kind of like deconstructed out of that parameter, and I don't have to do any of these intermediate variables that I can't come up with good names for. So the recursion thing. So going back to our example with 27. So 27 gets passed in here, and this is this list, right? We've popped the first item off, which is X and 10 in this case, right? So since our number is currently 27, we're going to divide 27 by 10, because we have 10 here. That's going to give us 2 remainder 7, right? So we're going to repeat X 2 times. So this side of the function is going to be X, right? And then this symbol, this is the string concatenation operator in Elixir. So it's like dot in PHP. So we're going to concatenate that with a recursive call to numerals, passing in the remainder and the tail of our list. And I feel like it just happens to work this way. Conceptually, maybe we should pass the whole thing, but it doesn't really matter because there's no way that X is going to match on the remainder. Otherwise, our remainder would have been higher, right? So this is probably more performant. So now what we're doing is we're calling numerals again, but we're passing in 7 and we're passing in this list. So now we basically have like a set of brackets here, right? Where we're going to say, okay, 7 comes in with IX. IX is going to go in 0 times, remainder 7. So this is going to match against this one because the remainder that we're passing in is 0. And that's going to return an empty string, right? But it's going to return an empty string concatenated with 7 passing in. Okay, so it is important that we do the tail. Good thing that this is occurring to me now. So now we're going to get this this chunk. So now we're going to go 7 divided by 5, which is going to be 1 remainder 2, right? So now we have like basically another nested set of results here. So we're going to get v times 1, and then we're going to pass in the remainder 2 into the numerals function with the tail, which is going to be iv and I now. And 4 is not going to divide in, so we're going to get another 0 case. And then it's going to pass through again. Actually, yeah, it's going to pass through again, and we're going to get I times 2, right? So this is going to end up concatenating with empty string, which concatenates with I, like that. So now we're going to end up with XX, V, I, and if I did it right in my head, yeah, that's the same thing. I almost confused myself for a second there. I was kind of worried that when we match this one, does it not call in with the remainder? I kind of feel like it shouldn't, but it's working, so I'm so confused now. So let's think about this case again, where we had, I guess, this list, right? Came in, so our head was IX9, and our value is 7. So we're going to have 0 and 7. So it's going to duplicate it. Sorry, 0 and 7. So our repeats are 0. So we're going to duplicate 9 0 times. And then we're going to pass it. Okay, sorry, we're passing in the remainder. So it's only when the remainder is 0 that we do nothing, which makes perfect sense. Okay, back on track. So let's run these again and see where we're at. Okay, so currently green. Now we are in this situation, 48. So what's 48? This is failing because we're trying to do 4 x's. But I'm guessing 40 is a special case. So I'm just going to add it because I'm pretty sure that's got to be true. XL must be 40. Yeah. 59. So this is going to fail because we're going to have to add L for 50. So we'll do L is 50. And we're green. And 93. XC. So I guess there is kind of a pattern that explains like how the one before the next one works. I still don't know if it's consistent enough to like generate it versus having to have like a map like this. So we're gonna have to add LX for 90. Oh, sorry, XC for 90. Okay. And now 141. So we're missing C. Let's just run the tests and we'll see that we need to add C for 100. And then 163. This might just work. Yep. CDII. So I guess CD must be 400. Cool. 575. So this one's going to fail until we add D for 500. Next one is 911. So this is going to fail until we add CM for 900. I'd like to look at some other people's solutions to see if people are doing the same thing with special casing those ones, or if someone figured out a clever way to do it. 2 tests left. 1024, so this is just going to be adding M for 1,000, I think. Good. Now 3,000, which I think will pass on its own. Beautiful. So, one thing that we could do is we could inline this if we wanted to, right? To get rid of that intermediate variable. Might be a little bit confusing, but I think it's fine. And if we do that, one thing that we could do too is we could collapse this into one definition and use like a case inline match, but I think this is okay. Yeah, so still good. I like it. So let's submit it. Roman numerals. And let's check out exorcism and see what other people did, because I don't feel too bad about looking at other people's solutions once I actually like write a solution that I like. So, okay. See what other people got here. I like how this guy is always submitting things like 8 hours for me. Woo. Yeah, ours is nicer than that one. Oh, that's cool. Div mod. Where's that? Did he write that? Oh, he wrote that. So div mod like does a integer division and returns the result and the remainder in a tuple, which is kind of cool. Gross. I don't know. I feel like our solution might be like the best one. So that's pretty cool. I'm into it. Do I dare pull down another one? Yeah, I like ours. I'm happy we thought of like a clever way to do it for sure. Using the recursion and passing through the remainders. I don't know. That seems pretty slick to me. Binary. This is I'm intimidated already. Write a program that will convert a binary number represented as a string to its decimal equivalent using first principles. Maybe that's not that complicated actually. Yeah, I agree. The IVIX thing, that would have been neat. I'm still kind of wondering, like, is there one for every single one? So there's a 4 and a 9, a 40 and a 90, a 400 and a 900. Yeah, so it definitely is generatable. It's just a matter of figuring out like a clean way to do it, because you have to kind of know what your base unit is. You know what I mean? It's like this needs to know how to look back 3 items to know what to subtract like from the next one. I don't know if we could have done it in a way that was not horrifying. But yeah, it's still pretty good. All right, so before we look at this one, I want to remember how we did math.pow. Okay. Okay, so we want to convert a string of ones and zeros into its decimal equivalent. It doesn't seem like it's going to be that complicated, to be honest with you. Oh, no, shit, wrong one. Okay. So, again, let's think about it in terms of like a transformation. So, one, 5, 9. Yeah, is it times 10? Yeah, it's times 10 every time. I think the tricky part would be like stitching it all into the right ordered list like this. But I guess you could generate them all and then sort based on this value. Yeah, I don't know. It could be fun. I'm not gonna worry about it right now. So with this one, the algorithm that I'm thinking in my head, right, is like basically we want to take every element and we want to, if there's a 1 there, we want to return 2 to the power of that index. And if there is a 0 there, we want to return 0. And then we want to add them all up. The tricky part is it's not actually the index, right? Because this is reading left to right. So the index 0 here, this is not what we actually want. So I'm thinking what we actually have to do is we actually have to reverse the string. And then reverse the string, split the string, do some sort of map with index. Let's see if enum has a map with index. Because that's the tricky part, I feel like, here. With index. What's this do? Returns the enumerable with each element wrapped in a tuple alongside its index. Unbelievable. Okay, so let's just write this on the first try and have every single test pass. So we are going to call, how do you reverse a string? String.reverse most likely. These are fun problems. It's been a long time since I got to like do interesting problem solving, like sort of brain teasery problems. So it's fun to do this. So, okay. So we're going to take the string, we're going to pipe it into string.reverse. We're going to pipe that into string.codePoints. We're going to pipe that into enum.withIndex, right? Is that what it was called? Enum. Enum with index. And that starts at 0, right? It's a 0 indexed thing. What the fuck is this version? Oh, offset. Okay. All right, so enum dot with index. And at this point now, assuming that we started with a string, let's just say to be real obvious, we started with 1 0 0 0. So let's just, maybe we'll do it in comments over here. So if we have 1 0 0 0, we reverse that, so we have 0 0 0 1. We get the code points. So at this point we have a list of 0 0 0 1. Enum with index. So this one is interesting because now we get tuples back, right? So now we get a tuple of, is it index first? So they're using like a keyword list here, but it's the same thing. That's just syntactic sugar. So we're actually getting, so what is it? Element and index is the second one. So here we're going to get 0 0, and then a tuple of 0 1. Then a tuple of 0, 2. Oh shit. Tuple. 0 of 2. And then a tuple of 1, 3. Right? So this is kind of what we're left with at this point. Now we want to map this. And we're going to pattern match in our thing here to get the I wonder actually, let's map these into I'm thinking, like, do we want to map these into like true, into Boolean values? I wonder. Is there like a string to bool? Obviously we can do it ourselves, but let's just try it. We'll do enum.map function. I guess we'll call it char. And we want to return I guess we just want to return char triple equals 1. And now we're actually going to have true, true, true. So no, other way around. False, 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 true. So this is going to tell us like whether we should include that value, right? So now this is going to be like include and I guess power, right? So actually, you want to see something cool? I just learned about this today, but I can't remember how it works. Elixir anonymous function pattern matching. Pattern matching. Anonymous functions. Have I been using brackets where I don't need them? So we can do like true in power, and then we can return math.pow 2 to the power of power. Otherwise false and power, which isn't going to be unused here. We can return 0. And now that we have a map of values, we just sum them up, right? So I think it's just enum.sum. I don't know. Let's see. Probably syntax. Beautiful. First one is done. And let's just cross our fingers that we are just so good that we got all of them right off the bat. Second one is done. Third one is done. Fourth one is done. Fifth one is done. Done. Let's cheat a little bit and uncomment them all. What? Except these ones, since there's invalid cases that we have to handle. Okay, so all the ones that actually matter are good. The rest is just like stupid validation cases. Trying to think of, there's one where I had to like throw an exception. It was validate something. So what are they expecting us to do? Raise an argument error? Oh no, just return 0. What is the cleverest way to just return 0 for the whole thing? It's annoying that this is actually the most complicated part of it, I think. At least to do in like a way that we think is cool and that we can be proud of. Like, it'd be sweet to be able to pattern match on the string and like guarantee that it is made up only of the values that we want. I mean, one way that we could do it is to do a con statement. Two spaces, damn it. Something's in the wrong spot. Anyways, so we could do something like this. And here, I think we want to do like a, I guess just like a regular expression match. So there's a regex module. Actually, I think there's a string.match function. Create a list with 0 and 1 from input string. I guess like the problem is I'd have to like bail early if the tricky one is this one or this one. You know what I mean? Like, so it's going to be valid, valid. Oh, all of a sudden it's invalid. And because they want to return 0 and not raise like an exception, I have to somehow like detect it in advance. How many katas have you done with Elixir? So we've done all of these ones in the sidebar so far. And we started on, I don't know, Sunday, maybe? Sunday, I think, was the first time I wrote a single line of Elixir. So we've got 1, 2, 3, 4, 5. We skipped this one. 6, 7, 8, 9, 10, 11. We skipped this one. 12, 13, 14, 15, 16, 17, 18, 19, 20. 21 so far. And I know how to do the ones that we skipped now. We skipped these two that used a lot of date functions because Elixir doesn't have date stuff in its standard library. And I had no idea how to do any date stuff. But I did a little bit of research today and found out that you can work through it in, you can use the Erlang calendar module and you can just call into that. And it was a lot easier than I was expecting it to be, like doing the interop between the two sets of modules between the two languages. So I might go back and do them after. Anyways, so if we want to do this string.match thing, check if string matches the given regular expression. So I guess we just want to do string.match, and it's going to take the string, which is our string here, and then what's the regular expression going to be? Our start of string, end of string, and then I guess 0 or 1 or more times. Actually, I guess we want to match if the string contains anything that's not 0 or 1, we want to return 0, right? So I think that would be right, in which case we just return 0. This like looks really stupid, so I'd like to see what a better way to structure that is. So we're still good if we comment out this one. Okay, yeah, seems to be working. The validation case sort of sucks. So I don't know if we need to do this map, because I guess we could just pattern match like this, right? The with index thing seems important. Got two dogs here that don't see each other often, and they're losing it upstairs. But everything else seems okay. It's just this like condition block to like do the, I don't know. Let's submit it and see what other people did. That seems more complicated than ours. So where are they getting the exponent from? Oh, so they're doing this by iterating and using reduce and passing an accumulator and manually increasing the exponent. Seems like pretty weak sauce compared to this bad boy. Let's just delete this actually. Strip that white space and resubmit. I like this pattern matching on an anonymous function in a map. That's pretty sweet. Never did that until today. Sorry, I got distracted here. So what's happening here? When is binary string? That's kind of cool. That's kind of what I was hoping we could do. I just didn't know that that was actually possible. So there's an is binary function in the kernel that is guard clausable. Is binary. Doesn't actually look like that does what I thought it did. So that actually doesn't do what we were expecting, but this is kind of cool. This guard clause here to make sure that the head is 0 or 1. So